So my name is Andrew Sakowicz, and this is my colleague Frank Pizzi. We work in professional services. I've been doing consulting for past 16 years. And this presentation is mainly to tell you how we tackle performance and scalability, focusing mostly on ArcGIS Enterprise. But the practice of performance tuning crosses all architectures. So we have some field experience stories. We'll share practices, tools. You will have access to all these tools. And it's really a summary of how we tackle this topic. It's an important topic, performance and scalability. But before we dive into, what is ArcGIS Enterprise? What are the key components? Well, I'm sure you're familiar with this. You know, on the top, it starts with portal, ArcGIS server, ArcGIS data store, ArcGIS web adapter. Let's just take a picture. You know, how does it look? So, you know, on top of it, we have portal, hosting servers, ArcGIS data store. You know, ArcGIS server is federated. This is really to set the context of what are we focusing. Let's quickly talk about ArcGIS server architecture options, what they are, and how a selection of given type pattern can impact performance and scalability. So, first, I want you to see the area in the middle. It's the site. A site with multiple nodes, federated, with a shared configuration store. It is recommended architecture from now on. This architecture cluster is going to be deprecated. How many of you have named clusters? Okay, good. Not many of you, but if you're wondering how to move from named clusters to this new architecture, well, you either need to put all the nodes under one site, or you can create multiple sites. But I want to talk briefly about how selection of this architecture can impact scalability. So, if we look at the silo, has a lot of benefits, but also the downside is that we can't really federate, and so it has still usage if you have simple ArcGIS server-based deployment. We use this model in the cloud deployment or when we have a load balancer. So think about how do we scale horizontally? We're kind of talking about scalability. If these towers are identical, all we need to do is just attach another tower, to the load balancer, and it can quickly scale horizontally. Amazon has elastic load balancer that we can leverage. The same if you have a hardware load balancer. So it's a very easy way to scale horizontally. The downside of this is that if you publish services dynamically, you will have to synchronize them. So probably the ideal situation, if you have a very simple web GIS with relatively static services, that would be very still valid. But we hope that you're migrating from this very simple to the ArcGIS Enterprise based on the hosting servers and federation, and really you need to do that. And this horizontal scalability is if you know you're just adding node and it will automatically publish the services. What are the things that you should consider when you're managing the site? They are all very sensitive and dependent on the infrastructure resource availability, like network stability. Remember that they have shared resources. So these nodes need to be talking to config store. and the network is not available, it will impact stability. The same with storage device, where we put this config store and output directory. They need to be available all the time. But also performance of that needs to be satisfactory. Because if you put the config store on a slow NAS, everything will be slow. We're reading from this config store all the time. So it's very important to do that. How do I know this? Because I have many experiences where we will get into ArcGIS Monitor and other tools. When I had the strong hypothesis that NAS is very slow. And at that time, I didn't have tools to have a compelling story to IT that I really think that the NAS is very slow. So my poor way of proving this was taking the config store from the NAS and putting this on a local disk, and it was just a quick validation. So I assure you that there are many cases where the performance can be improved drastically by improving throughput on the NAS. And then other elements like RAM and CPU. How many of you have more than 100 services on your system? Okay, so you already have experienced, that RAM becomes a hot commodity, yes? You can't just publish services. You need to manage that. CPU becomes very important when we're dealing with a high number of users. Moving down, what are the things that we should be avoiding when we're dealing with sites? Publishing high number of services. When you publish, it's a really resource intensive. So unless there's a strong requirement to do it during the working hours, I recommend that you do this off-peak hours, not to disturb the system. The same with adding or removing nodes. These operations should be done off-peak hours. How many of you change recycle time? Those of you who raised your hand for 100 services, how many of you changed recycle time? Excellent, okay. Because you've probably logged in at midnight to your system and you're scratching your head. Why is it so slow? Well, it's busy recycling, yes? So if you have all these services, they are being recycled. So make sure that you change that. What other things that are important for ArcGIS Enterprise management? Identify unused services. I'm still, staying with you, those who have the high number of services. It is unlikely that they all are being used continuously. Some of them are being used, some of them are not being used. So if you have enough memory to set configuration for all of them, that's fine. But if you don't have enough memory, you need to come up with the algorithm, what needs to be reduced and what needs to be increased. So we need to just manage this. And there will be later about that, the tools and how to do. Also, tune slow services. Why this is so important? Because if you publish a slow service, what will be typical reaction of a user? They will click on this and it will be slow. I know that I cannot be patient beyond 6 seconds. After 6 seconds, I will do something. Probably just like you, I will repeat this operation. So I will click it again, yes? And maybe again and again. And now it's just miracle that one user can create a load on the system equivalent to maybe 10 concurrent users. So just imagine if you have 10 concurrent users using the same thing. It doesn't take a lot of users to actually put so much load on the system that impacts performance and stability of all others. So it starts with tuning. How many of you have the setup where you are responsible for managing GIS services, but they are actually being published by users in a different department that you're really not controlling them. Okay, all right. So you're sitting on the receiving end, and it's just like, yes, and you're catching this. So if you have all the tools, you catch that, but it's challenging. You know, ideally, we want to provide users the best practices. We want them to maybe run MXD perfstat before they publish map service. How many of you are familiar with MXD perfstat and using? Excellent. Okay. But the question is, you admin people, you're very familiar, but are your publishers familiar with this? Because oftentimes they might be scientists, they might be geologists. They don't really want to spend time learning about GIS administration. They just want to publish information. So we really need to provide these best practices to publishers, because by the time it gets to you, it's a little bit too late. And then you can go back and you can identify. But if you have these hundreds of services, you probably want to have a tool to quickly give you the list of services that are slow, they need to be optimized, yes? And we will talk about this in a moment. Yes, we have these tools. If we absolutely have to manage high number of services, then we really need to watch for memory, not only physical, but committed memory. And we'll talk about this later as part of monitoring configuration, that we really need to have a quick tool that will give us the spec of all the servers that we configured and quickly see how much memory is allocated and how much page file is allocated. So if you have a large system with many servers, it's difficult to pull that information unless you're super organized and you maintain your Visio. But other than that, it's probably, I need to remote desktop to machine to quickly check these specs. And if you're adding and removing machines, it's actually hard to figure out what we currently have. So I mentioned CPU and network. And as in the slide, all of it is available as part of, now it's called ArcGIS Monitor. This is the URL. You could click on it up to the portal. That's incorrect. And I'll give you this URL in a moment. So a little bit more about publishing. You know, we have this model of ArcGIS server and app. So we have, 4 services, and we publish and consume by the application. With the WebGIS, we really want to have maybe ideal one service that creates multiple representation of that using web maps and layers and consumed by app. So how does it look here? So what we have is we have a wells feature class. We create a feature service wells, and then we have different representations. What I see on many sites that I see the same root is like wells, my favorite, wells 1, wells 2, wells 3. There is a duplication of services that address the same thing. So that would be the first area that we can address, is make sure that it's not the case. But back to those that do not control your publishers, you simply cannot control them. So they can publish as many services as possible. So we were trying to have a practical approach. And our practical approach is educate your publishers, but also have monitoring tools that will quickly identify things that need to be optimized or duplication, that you have duplication of services. How many of you are using hosting server publishing? Okay, so the benefit of that, the scalability, comes from the fact that there is no more ArcSoc. So we remove this requirement for memory, and therefore we can publish and consume many services. So we literally remove this layer of the ArcSoc layer, and that's really cool. It's very scalable. let's talk about from the process, how do we manage performance and scalability? It starts, so this is project lifecycle. It starts with gathering requirements and architecting the right design. So we have a system design, and as part of the output, we should have capacity planning based on the requirement. So if you have a brand new design and you have really no historical information, you need to start with some rational models and design. As soon as you go into development, as soon as you have some services which are the engine of your solution, you should start testing to get the sense of what needs to be optimized. And then when we go into deployment, monitor. And we have these tools and services for each of these milestones. The focus will be on testing and monitoring. We will just barely touch on the architecture and capacity planning. So I mentioned if you have a brand new solution that there is no historical data, you need to start with rational models. But most of you are in a situation when you have existing GIS and you're adding more capabilities. So it does make sense to monitor what you have, maybe run a load test for what you're envisioning, and take these two inputs into your design, and then your capacity will have better calibration, it will have better accuracy. So we are proponents because we run the lab and we have the tools. You know, our paradigm is empirical. We want to measure and we want to use this information as opposed to rational. I will just use hypothetical models. They both are available, both valid, but I feel that acting on the data that becomes information provides us better accuracy than rational models. Because what is our historical experience with insights? Yes? So if I have to measure, I have to test this. I can't have a theory about the modeling of these technologies. So we have to test everything. Let's move on. So tools. Tools are just that. They're just tools. Without knowledgeable users, they oftentimes are not a very effective way. So we need to have a discipline, we need to have practice, we need to have experience. And this experience needs to identify the patterns. So then when we log into a tool like ArcGIS Monitor, we already have a hypothesis. We all have a mental roadmap how to use it. As I mentioned, the tools that we'll be discussing here, they're available to you. I'll take a moment for you if you're interested to take a picture of that. But if you go to ArcGIS Online and you search, by that, you will. So you see the search owner equal Enterprise imp, and they will list all of them. With the exception of ArcGIS Monitor, you will see the old system monitor that will reference you to this page. How many of you heard of ArcGIS Monitor? You probably saw something in the plenary, yes? Very well, thank you. Well, some of you might be interested, and I hope all of you at the end of the session will be interested in ArcGIS Monitor. We're very excited, and there are a few of my colleagues, Frank, who is a lead developer. We have Garrett, who's a product manager, so he can talk about when it's available and how to get this, and then we have Jennifer and Bruce, at the back. We're very excited. So please log into this, provide your name if you're interested, and we'll spend quite a lot of time explaining, how we use these categories. And this session will be not so much about the tool, but the practice. So we'll be using these views, but you certainly can and should have these views in any tool. And if you are interested, you are free to go to our demo. And this is the URL. And you can click along with Frank, so he will be giving demo, and you can just do it yourself. So let's move on. Definitions. It helps to understand the difference between performance and scalability, and how do we measure. So when we say performance as part of tuning, as part of monitoring, what are the counters that we are looking for? They all should have the units of seconds or maybe milliseconds, but it's a time, yes? It's how long, what is the response time? If we use the speed analogy, a car, it's just the speed, how fast they're going. But performance is only one aspect. Performance is related to scalability. So what happens to the performance? What happens to the speed that we're traveling? We're adding more and more users. It's getting slower and slower, and that's to be expected. And it helps to have this analogy in your mind because every freeway has capacity. So if you are over capacity, you remember that's why I was talking about the CPU and memory and all other things, that this defines the capacity. If you're over capacity, you will be in this condition. It's not desirable, but it's actually one of the easiest problems to fix if you have enough tools and a quick awareness of what is the root cause. Because how would we fix this problem? Well, we can put the traffic light and control that, or simply build many lanes. So from the analysis point of view, it's very, very easy to troubleshoot that. It's a little bit difficult to handle bottlenecks. So think about this. There's a toll booth, and we have only one toll booth open. So the CPUs, these lanes are like CPUs. We have big machines with 32 cores, but there's only one instance, one ArcGIS server instance open. I hope everybody is familiar with ArcGIS server min and max instances. How many of you change the default settings when you're publishing? Excellent, very well. So you already are very advanced. Now, how many of you are increasing these instances and also watching your memory consumption at the same time? Very well, excellent. Well, then I don't know if I have anything to add. Well, that's really good that you're doing this, but I'm sure that there's a group that... So let's really quickly validate how the system behaves under load, because it helps us analyze testing, but also monitoring. There will be two categories of counters. This category is a user counter. So this is the user perspective. So what do we have here is how many users are coming on the system. So 1 user, 2 users. And as we add more users, as we add more cars on the freeway, the performance is slower and slower and slower. And I like the throughput for determining the user load. You see that we can use two definitions: number of concurrent users, it's the steps, and throughput, the transactions per hour. I like the transactions per hour, requests per hour, because it kind of abstracts the user productivity. One user can be panning and zooming all the time, and another user can pan and have coffee and discussion. So comparing users is not as effective as throughput. Okay, so remember, when you analyze the system, especially if you're using any type of monitoring tools, you always need to put first the user hat. If you are a network admin and you're just using, switches analysis and all the low-level analysis, you might be tempted to immediately go into network utilization and bandwidth, but that's not what I recommend. Always start analysis with the user. Because if the user doesn't have problem, then all the other analysis are become academic or just low-level technical analysis. Ultimately, what we really want is to address the user problems and correlate them with other utilization. So let's say that we have a performance problem here. We clearly see that this throughput is kind of leveling off, so it's almost like we're over capacity. But let's see if we overlay this with the IT counters, which is the server utilization, CPU and memory. You see that this throughput, the user load, and CPU utilization, they're aligned, and most likely we are reaching the capacity. So if we're over the capacity, this is what happens to this performance. We do not want to go over the capacity because look at the slope of this curve. We pay a lot of penalty being over the capacity. So now I think it's really helpful to have tools to quickly identify what this capacity is and react. If you have a cloud solution, we use auto-scaling. How many of you are using cloud? Okay, how many of you are considering moving to cloud? Very well, and then this is one of the reasons that you simply cannot buy 100 physical machines for 10 hours per year, yes? So if you have sudden spike in the cloud, it will just auto-scale and it will shrink and you pay for these 10 hours. And there are many other valid. By the way, we, in professional services, we manage a program called Managed Services. So we host solutions for our customers. That's why I'm very familiar with this. And also partially, that's the reason why we developed the ArcGIS Monitor, because we're using this, for our own internal needs as well, not only for consulting. So back to this. Remember, there is user counters. So these are the user counters, response time, number of users, throughput, and then the IT infrastructure counters, CPU, network, memory. And it will become easier for you to navigate the menus of ArcGIS Monitor if you understand these distinctions and also correlation. So let's just think about what I would do, how I would analyze performance using ArcGIS Monitor. I would go and identify user response time counter to verify that it's indeed slow. Yes, so you get a phone call, system is slow. You need to go and find the response time counter in ArcGIS Monitor. Say, yeah, I got it. Okay, I got it. Now that's not enough. We only validated what our users are already telling us. Now we need to figure out what is the root cause and how to fix it. So I would immediately go and see, did we add more users on the system? Oh, okay, well, maybe it's related to the increased user load. And how is our CPU utilization and other resources? Okay, so in that case, it's just the issue of the capacity. And as I mentioned, we just need to add more resources. It's a very simple way, but this is how we use monitoring tools effectively. And it will be a little bit more on that, how to be organized. Because what I really want to say is that there's a lot of data, and we need to turn this data into information, and we need to turn this information into action. And that's not easy. It's very easy to have a lot of data. You can download dozens or hundreds or even 1,000 tools, or have a subscription, and they will just suck the data out of your system, and you will have access to this big terabyte cube of data, and they will give you a querying language, and you're able to query, and you can group by and everything, but that's not enough. Actually, the real value is knowing the querying, knowing the group by, knowing how to correlate. That's the value of monitoring tool. So when it comes to testing or monitoring, it's very easy to install things and click next, next, and configure. If everything is okay, that it's sufficient. And I do not discourage anybody from not doing this. But when you get a puzzle, then in that case, you need to have the knowledge of configuration and tuning. And what does it mean? What does it mean in terms of the depth? What does it mean? So let's go through the typical tuning case. The first thing is, how do we start? How do we start? Oftentimes, we start with what we're familiar with. So if you're a DBA, you start at the database level. If you're ArcGIS server admin, you start at the ArcGIS server. If you're application developer, you probably start at the application developer. If you're a network, probably you're looking at the network. And that's how often things happen. We meet in a big room, round table, with all the admins, and we just talk about the system problem. My way of tackling this is not from the bottom, not from the middle. Start from the top, talking to your user. So, because, you know, how many of you have said or feel like saying, nothing works? Well, we kind of need to break this elephant into something smaller. Yes, we need to be able to act on that. So that's probably not correct assessment. There's operations that are slow. So we need to quantify them. We need to sit down with the user. We need to open an application. We need to click on this application, and we need to Fiddler or profile that. How many of you are familiar with Fiddler or the F12? Yes? Okay, excellent. So, you guys, I'm surprised you're still sitting here, but please stay. So those of you who run the Fiddler for the web application, you know that it's like all these requests, and sometimes it just page changes, yes? So you record all of it, and you identify the time of the slowest, and then now we narrow down from the application to one URL. So it's already big progress. Now, the second thing is, we always want to, when it comes to monitoring, we always want to leverage the history. So we want to see, is it a recent event or something chronic ongoing? So I'll show you the several tools of doing this. But before we switch, what else can we learn from that? So now we kind of need to be a little bit detective and look for details, and you Google and other things, because with this little help, we can take it very, very far, this tuning. The first thing is that we identify it's a map server. It's an export map server. What's behind map server? How do we publish map servers? Using what? It's an MXD document, yes? So look at that. We had a big web application with nothing work. Now we're down to MXD. That's a big progress. It's still a ways to go, but impressive progress. But how do we quickly identify the history? Well, in 10.3, ArcGIS server comes with statistics. You can use it, and we use it. The benefits. You can use log parser. It's one of the tools that we have available. You can use ArcGIS Monitor. All of them will allow you to parse history and identify the trends, historical trends. But back to our case. So we have the MXD. Now, how do we troubleshoot MXD? So many of you already mentioned MXD perfstat, yes? How many of you are using MXD perfstat again? Okay, well, actually, there is an opportunity for some of you to be introduced, because there are many others in PerfQ Analyzer. They're all doing the same thing. They're breaking down response time for each layer. So in that case, notice that we have this response time, but also it talks about Oracle, CPU, So go back to these layers, that it was a browser and database and ArcGIS server. If the total response time at the was 5 seconds, and then it says that the database CPU was 4.7 seconds, where is our time spent? Where is our culprit? It's the database, yes? Most of the time was spent at the database level. So here's where most reasonable people will throw a towel. It's like, okay, I'm done. I'm not going any further. I will give it to somebody, my DBA or maybe professional services or a business partner to handle. But if you're adventurous and you can quickly Google how to trace it, and you trace, and you get this. And if you're really looking at that, you will see that this is actually spatial query. And if you use I said every tool, every monitoring tool has this performance, no matter how is it called, duration, elapsed, response time. They all have it. So now we've reproduced the problem at the database level. We don't know yet what causes this, but databases, RDBMS, is just like planning your travel. Should you take local streets or freeway? It has the same execution plan. Should it use spatial index or not? So if you click here, and it will tell you that actually the problem is because the spatial index was not used. Now, you might be completely new to this, but with a little research, you can quickly convert that name to spatial index, and then as a GIS admin, now you know what to do if spatial index is not available. I am doing this only to demonstrate that you already can do a lot. Now, whether you can go all the way to the execution plan, that's for you to decide. But I recommend that you use these tools, MXD PerfStat, Fiddler, ArcGIS Monitor, to start utilizing, because it can be very effective. In other cases, with the number of vertices, so you see MXD PerfStat shows you that this feature class, just 500 features, but it's 7 million vertices. In that case, you need to simplify the geometry. I hope that you have a sense that it's actually not as difficult as it might sound, and with the right tools, you can quickly demystify what the problem is. Testing. Well, that's another important thing, load testing, to determine SLA, identify bottleneck, determine capacity, or compare alternatives. We always start with comparing hardware, because hardware is not equal, especially if you're comparing physical machines to virtual, or maybe one cloud vendor to another. It's actually not very easy to normalize spec rates across all these vendors. So it's nice to have some sort of empirical way to testing. I use Sample Word City. Everybody is familiar with Sample Word City? That's my benchmark. Oftentimes I just run a load test, on one machine, and using that, and I compare. And there are other synthetic tools. And then the GIS services, that's the engine, so we really want to test that. And finally, the application. The tool system test for web that we developed, it's GIS aware of. It understands what to do with these services, so you right-click on them. It's very easy. We can record the application, web application, even if it's not part of Esri. It still just treats this as a web application, and you can play back, and there are reports. There are many excellent tools, and we recommend that you continue using all of them. But I hope that you see the value of the system test. For the most part, that has this GIS data generation is aware. It's aware, GIS aware. In addition to this, it's free. We think that it's easy to use. Now, in some cases, users are using system tests to generate the data, and they plug in into other tools that are familiar, like JMeter. So what do I mean by the GIS data generation? What I mean by this is that you start load testing with a map, and you zoom in into the area that you need to test. If you don't have a map and you write some algorithm for load testing, you might not realize that in your algorithm, if you write some B-boxes generation from starting with 0 and minus 90, you might actually find yourself that most of your test is going into these empty areas. And clearly your test will be skewed. You might feel good because the performance will be phenomenal. You'll be I will not have time for a demo, but I encourage you, download this tool, open help, especially this dynamic map services, literally just walks you step by step by step by step. I am certain that you can make it work. When it comes to analysis, after this session, you should be much more confident. So let's move on. And there are advanced features. The output of that is also a model. So this is Excel report, and this curve is actually the model of the operation. How many of you are familiar with capacity planning tools like CPT spreadsheet? Anybody use that? Okay, so you remember you're selecting the models, yes, like small, medium, large. And these models are kind of a representation of that. Our approach is a little bit different because we have access to all these tools, testing tools and monitoring tools. So we rely on testing. Instead of us using small, medium, large, we probably will run a load test quickly to get this number, and we would plug this number into another tool that it's available to you called System Designer. So the model will go here, and we click calculate capacity, and it will tell us, how many cores and how many machines do we need for our solution. So let's keep going. So that leads us to the infrastructure capacity planning, the one of the important elements. Something that it's relatively easy to do is to plan for capacity for our ArcGIS Enterprise. As I mentioned earlier, we start with CPU because most operations are CPU bound. Memory, when you have a large number of services, you really need to know how much memory you need. If you're dealing with imagery or any type of I/O synchronization, why do I have synchronizations? Let's say that you have Collector or other apps and you have photo attachments and you just synchronize them. Believe it or not, you will generate a lot of I/O on your system. So you really want to make sure that you have solid disks. Actually, when I say solid, I meant this as like good disk, but no, buy solid disk. They're also network. Yes, if you are dealing with a high content and remote locations. And finally, virtualization. Make no mistake, virtualized machine will not match the performance and throughput of your physical. It is possible. Actually, a colleague of us traveled to Palo Alto to VMware, and they set up a test, and we did match physical throughput to the virtual. But we really had to allocate almost 30% to the hypervisor to achieve that. And that just defeats the purpose because virtualization is to reduce your cost. So that number is quite okay. Like if you experience 30% performance degradation moving from physical to virtual, maybe from physical and now you're going to cloud that is using virtual, that's not a bad number. So don't overreact. Now, for those statisticians, 30%, it's a terrible number. But if you start with the tuned system, if your service takes 0.1 second, and we add 30% degradation, so now it's 0.13, and nobody would hear this tree falling in the forest. So now if you start with, 10 seconds, the 30% actually will be a little bit painful, because you're already really unhappy with this, and you're like, we're going to the cloud because, the performance will be improved and everything, and suddenly it's like, no, actually not. So tune your services, but also be, okay. So I have this slide mainly to tell you that it's better to use System Designer than figure out what this is. But for those of you who can break the equations, the key inputs, so we're calculating how many CPUs do we need. So the key input is throughput. You remember this TH is the throughput. That throughput, where can we get throughput? Well, we get throughput from ArcGIS Monitor. So I want you to see the link between capacity planning and monitoring tools. The service time, it comes from testing. So really, the key inputs is knowing your user load and knowing your cost of operation. This is, in my opinion, more difficult than that because this is kind of related to response time, so you can assume, oh, my map server will be relatively fast, maybe I assume 1 second. But throughput, that's hard. How many of you are dealing with public application, public-facing application? Okay, so good luck, rationalize, how many concurrent users you plan to have, yes? You start somewhere, yes? You just start somewhere, and the only thing you can do is monitor and adjust, yes? Monitor and adjust. So this number is very important. All right. So I really want you to walk away from this session with a couple of, points. Is you always need to know how to quantify your performance, no matter which tool you use. Look for these keywords: elapsed time, duration, response time. And the second thing, you always need to know popularity of your services, which is measured in throughput, transactions per second. So performance and user load. We use the same numbers, throughput, to determine how much network we need. So that's how we calculate megabits per second. Or oftentimes we need to estimate what is the performance, you see, seconds. What is the performance if we move this file across that network? And I did say, all built into System Designer. So if you're already tired of these equations, just use System Designer. It's actually a cool tool. It does a lot of things. Produces the Visio, produces quick capacity. We in professional services, we do a lot of that remotely. So that's what we do. All right. So I think that you understand the importance of capacity planning. How are we doing on time? Okay. All right. Okay, because he has all the goodies, so I'm just talking here. I'll speed up. Why do we need to monitor? Because when we go to customer site, this is the reality. We have multiple administrators, multiple monitoring tools. Oftentimes, data is not collected. For example, network tracing, that's only done on demand. So if we had a problem a couple of days ago, correlation of data is difficult because they're coming from different tools. You, as an admin, sadly don't have access to these tools. So in some cases, it's the first time that you are introduced to them. And therefore, it's challenging for us to quickly get to the root cause. Because we as a consultant, and yourself, we're fighting against time. So oftentimes when we go on site, we have 3 days. Sometimes if our customers are generous, they give us 5 days to fix the problem. So the idea is not that we don't have tools or you don't have tools. We need effective tools. We need something that we can quickly identify the root cause and make the recommendation. Because things get complicated, Like think about, years ago we had an ArcIMS or just ArcMap going to SDE. The architecture of that was relatively simple. Also, notice, in addition to the complexity, is how many things actually are outside of Esri platform. Certificates. How many of you run into certificates, they expire, and the user's complaining, yes. It's a silly thing like this, but the users actually don't see the difference between expired certificate and an ArcGIS server not working. They say, my GIS solution is not working. Therefore, we are in the business of everything, Certificates, load balancers, firewalls. Storage is very important. It requires this immediate consistency. If you really wanted to break that solution, all you need to do is to misconfigure this load balancer. Nothing would work. Or maybe make this break this shared content folder. Many ways for things to go wrong. Now. And I know that most of you have probably, well, you wear many hats. Some of you actually have multiple jobs, but most of us wear many hats. So we're a GIS admin and we IT admin, and we need to provide, do the budgets and project management. It's a race against time. It's a race against time. And that's what we think there is a value. What we're proposing is just simplifying, reducing the time for you to identify the root cause, and also for us. So we really need to have this big flashlight on the GIS, ArcGIS Enterprise. And back to our ArcGIS Monitor. This is our attempt, and it's not just a tool, but it's a really compilation of our experiences. Everything that you have it here, it's an experience from a customer side. Also notice, you remember when we were doing the tuning, we had web application on the top, and then it was ArcGIS server and the database, web ArcGIS database. That's not by coincidence. We order this in our logical order. You might have a different order, but this is how we approach the system, and that's how we align this. So it's really a tool developed by users. We're our primary consultant and users, and secondary developers. Frank is true developer. I'm not the true developer. But the value of this combination is that this is real. This is real to address real use cases, comes from a real user experience. If you compare our tool to maybe to others, you might say, oh, well, you don't have network switches and you don't take the DNA analysis. And we don't do it because we don't find this really needed for the things that we need to do. So there's another thing is, do not expect that monitoring tools will be your diagnostic tools. If you have a reproducible case, you probably should not be using ArcGIS Monitor. You need to be using other diagnostic tools. If you can reproduce a slow query on the database, you probably should be using SQL Profiler or Oracle Trace, not the high-level monitoring tool. I hope that you see the distinction. However, oftentimes one of the most challenging things is to have a reproducible case. And sometimes you will never have a reproducible case. You can only catch it and it disappears. And in that case, that's the value of this tool. So, for those of you who haven't signed up yet, the website is still open. Yes, Garrett? All right. For next. And that's me. And that's probably you too, yes? We all felt that way. So, the first thing I ask myself, well, is it us? Because I want to know, do I need to open tech support? Do I need to call our development team? Is it us? In a sense, we need to identify the way to fix our problem. There are cases they're used by might be VMware or NAS or Citrix or something. So the value is not only for administrators to detect and diagnose. The value is also for managers. Ultimately, that can lead to reduced administration costs, but more important, increased communication among GIS and IT. So if you are GIS admins, relatively new, or somebody who is completely firewalled from everything else, every time when you go to IT, you feel uncomfortable, you feel kind of a little bit stupid, like, they look at you and, well, now you will have tools, now you will have the lingo, now you will have a talking points, when you say, hey, Frank, so what is the over allocation on our virtual server? And they're like, oh, well, come sit, let me just, suddenly you will open many doors, And if you bring the MXD perfstat to your Oracle DBA and say, you know what, can we run the trace on this table because, it's a different conversation, as opposed to you call a meeting with all your admins and you say, well, GIS system is slow, so I need everybody to jump on it, and they will all like. So empowering GIS admin, and ultimately this will lead to user. The idea is that ArcGIS Monitor, or it's not to replace your existing tools. Absolutely not. Please continue using what you have, but get an idea. Use this as a reference implementation. So you see that we believe that it needs to be end-to-end monitoring. You need to have a web, and ArcGIS, and infrastructure, and database, and all of it. And that is the way we feel. So it needs to be end-to-end continuously. And if you can integrate and duplicate this in your tools, you should do that. What are the things that we've learned? Well, we've learned that oftentimes ArcGIS is not the culprit, but it's a victim. And what do I mean by this? It's very easy to focus on, to determine that just because ArcGIS server crashed or ArcGIS server is not stable, that's the root cause is there. And I will have kind of cartoonish use cases to show you that oftentimes it's not. So, if this is the ArcGIS server, I think it's okay if it complains a little bit, yes? When the knee buckles a little bit, I mean, that's so I'm not sure what crops are there, but just imagine the users or number of services. It's the same thing. It's a simple concept of overcapacity. That's another one, is unstable infrastructure. What do we mean by this? Well, I said it many times, I'm not going to repeat myself, but network, NAS, VMware, others. So obviously, it's I think you have my point. We talked about the bottleneck. So imagine this is ArcGIS server, and instances are not configured correctly. We have a lot of space. Everything is very well on the ArcGIS server side, but outside of the ArcGIS server, there are hundreds of users queued up, and the performance is terrible. And if you are ArcGIS admin that has only access to ArcGIS server, you will log in and you will say, everything is perfect. That's why I feel so strongly, you GIS admin, you need to have end-to-end. You need to know what is my queue outside of my system, because this is your problem, even though it's not in your ArcGIS system yet. This is your problem. So configuration, maintenance. How many of you use version geodatabase? Okay, so What happens if you reconcile and post and compress the database? It will get slower and slower and slower, and you will introduce these bottlenecks due to maintenance. All right, really quickly, we'll go through these major categories, and then Frank will finish with the demo. So what do I mean by web? So if you go to, by the way, you can go to our demo site, and if you click on web, you will see application validation, or at least a New York account. Application validation. What is application validation? Web application validation. As I mentioned, every counter from a user perspective will have the performance. So that's the response time. So you see this is the response time, and we have a little spike. Maybe it's a big deal, maybe it's not a big deal. Actually, little spikes are expected. But in addition to this, we have status quo, and we have content length. Frank will cover this in details. The HAR file. HAR file is, so this is, notice that we monitor individual requests. But wouldn't it be nice to record your initial page with 100 requests and see if all of them are successful? You might not be interested in performance of individual requests. You just want to make sure that all of them are successful. And then, so we have this HAR file, and you can see how many of them failed. And here, they will tell you the sum of all these requests. So you will see the overall performance. HTTP, it's just another counter for individual URL. What's in ArcGIS? Again, always look for performance. So here's just looking at the units. These are the units of performance. So busy time per transaction, that's a performance at the ArcGIS server. This is the throughput. This is the user load. What is the user load at the ArcGIS server? Busy free, these are related to instances. And this is the ArcSoc optimizer. So this is the new extension that we developed that allows you to reduce and add instances on all your services. So if you have several hundred services, that will be very beneficial because you configure and it will be just like an autopilot will adjust things. So it does analyze, past 30 days and a past day and makes these decisions. You set the thresholds, but it does the execution. It can save you a lot of time if you had to do it manually. Geo event. So again, it's throughput, for example. Portal, many simple stats, but quickly you can see how many users are on the system. So it helps us correlate the cases of user load to performance and resource utilization. Now the database, you see, so now we're getting into the weeds. Some of them, these counters are really low tech. So unless you're DBA, unless you've been dealing with version geodatabase, you will not make heads and tails of what it means, what delta records means. Now you can go to our glossary, you can read, but it requires a little bit of familiarity. So ArcGIS Monitor is not the tool for you to learn versioning. You need to learn the versioning and then use ArcGIS Monitor to, versioning. So we have many, and we'll be adding ArcGIS Data Store. It's important because now with ArcGIS Enterprise, we see more and more usage. The same with Oracle and SQL Server. So this area is growing for us. Cloud, Amazon, as I mentioned, we have this program managed services. So we use Amazon for many of our customers, and we configure this. You could go to CloudWatch and you can get these stats, but then you will find yourself that you need to log in here, log in there, and log in there, and it's just the value is in one place. Plus, we have some extra counters. Yes, they're not available out of the box. So you see, it's very easy if we want to have just one quick chart of CPU, infrastructure, all the standards, memory, CPU, so there is something here. I think Frank will demo this in a moment. Let's say remote ping. So we're an infrastructure. Think about this. If you have a site with many nodes, or maybe portal HA with many machines, so you just want to make sure that they're all talking to each other all the time without any type of latency. So you can set up this RPing. And here's an example where there was one instance that something was a little bit slower. Maybe it's a big deal, maybe it's not a big deal, but now you have the heartbeat. They're all talking to each other, and they can quickly validate connectivity. So it has a network in milliseconds and status code. This is a very interesting extension. Our colleague developed this to validate the health of the portal, especially if it's portal HA, because sometimes this high availability are getting out of sync, and we just want to know this very quickly. So here's the extensions with a lot of counters. This is another example that unless you're really familiar with the portal and high availability, it will be difficult for you to use this effectively. But for those of you who are, you will be like, wow, that's really cool. I think it's cool. VMware, I mentioned this. So, what is the lingo? So we have statistics again, VM host. That's something that you don't have access. Just think about this. You have a server, you have a virtual machine, and it has a task manager. But behind this virtual machine, there is a physical machine. What if this physical machine is completely consumed by somebody else? You look on your virtual machine like you have 100% CPU and 100% memory available. But the moment that you ask for this memory, it goes to this physical machine that has no CPU and no memory available. And you're like, what just happened? Well, the talking points are, how many virtual machines do we have on this physical machine? So it's a very simple question. What's the ratio? So we had this one physical machine. How many child servers we created from this one machine? What happens if the number is 10? And you might say, is it a good number or a bad number? I really don't know if it's a bad number. It's a really bad number if all of them ask for the resources at the same time. Oh yeah, definitely. And what I mean that, let's say that we have an 8-core machine and we spawn 10 VMs 8-core. So it will work if only one system asks for the resources at the time. But if 10 of them ask for the same time, they will be competing. The queue will be 10, so everything will be slow. And there are other ratios here. You can read on this, but when you start speaking this language, if you're a GIS admin and you go with these talking points to your IT and you say, I really think that we need more memory and CPU on our virtualization, and you bring these charts, believe me, you will get it. But if today you say, our system is a little bit slow, and I was just wondering if we add more memory, if this would help our performance, I don't think you will get that memory. Or unless you have a special connection. But every time I ask for more memory, our IT, they're like, why do you need more memory? So I need to prove that. Usage, what's popular. GeoInfo. I like this a lot because this is not just IT, but it's also for managers. For those of you who have a public facing, you will see who are your users, where they're coming from, and that's very, very helpful. From the marketing point of view. Okay, a license. So we parse LMUtil. We can tell you how many ArcInfo you're using, percentage, whose. So that's all available. And Frank, you take it away. Let's give it a live demo. Let's see how this is working.
Okay. So Andrew has spent a lot of time talking about all the things that are important to monitor. And this can lead to a great deal of data. And the very first thing that ArcGIS Monitor does is it tries to distill all of that data quickly to give you information, is something wrong? So this is our status page, and it updates regularly, and you can watch this page. And if you see that everything is green, there's an update. If you see that these are all green, the status is green, there are no alerts, there are no collecting failures, then you can know that your system is being monitored. Whatever you've defined to be monitored is okay. But in our case here, we're looking at a worldwide solution and simulation of 8 different accounts. We defined 8 separate accounts, and we are tracking upwards of 26,426 observations per hour. That's 26,400 checks per hour that you don't have to do. But there is a red dot on there, and that red dot, it's saying that there is one thing that is in some trouble. So what we do is we scan down to this, and we see that it is the New York account, and then we scan across, and we see the broad category here, Web ArcGIS database, and we see that it's infrastructure. Andrew, do you think that this one alert is important, that it could bring the system down?
Oh, absolutely.
So indeed it could. It could be you're out of disk, you're out of memory. We're not sure what it is right now, but we'll take a quick look at the very next thing, which is a list of all the concerned alerts. In our case, it's infrastructure, a category, it's a system. Here's the name of the machine that's in some trouble. The source problem is available memory, and we have 0.063 gigs left, and our rule is 1 gig, less than 1 gig. So imagine you had 50 servers, and you had to keep track of those. You had to go log in and check and keep track of memory, disk, CPU. This will take care of all of that. It'll notify you, and it's very simple to read in the status page. It updates all the time, and it can give you a lot of information about the status of your system right now. So why don't we just go over there and take a look at when the problem occurred. So since it's in the infrastructure category, we'll pick this category, and we'll head over there, and we'll see the alerting account. We'll see that the category is system that's alerting, and here is the item that's alerting. Let me quickly adjust the resolution here so that you can see it a little bit better. And here is our troubled machine. It's been in trouble for a little while. We'll go back a little bit. Okay, a little bit more maybe. And it's been in some trouble for a little while. And here it looks like there was a gap. And so I'm just on the edge here. You can kind of see where it kind of went down right there. And that's when the problem took place. And then all of a sudden it's been in trouble. So it's been in trouble for a good number of hours. So what we should do in this situation is go and address that problem. And part of keeping this page valuable and keep the emails low, when we see these kinds of problems, we need to go down and fix them and make sure that they turn green. And as long as you rely on the green aspect of it, you'll be able to understand the status. So if we browse these categories again, you can see that there's a great deal of items that you can set up. The web category is one of the popular items because it guards your system, because everyone enters your system through the web, and it goes through ArcGIS, it goes through a web adapter, it goes through a database. And so what better way to check to see if your system is up but by taking a few selective web calls. So here is an example of some web calls put together that it's called application validation, that is making an attempt to monitor a particular application, and indeed there's a real problem here, 62 seconds response time. So if we scan back here, we can see there's still problems with this particular element. And we'll get back just a little more, and that's where everything was kind of normal. So you can kind of see that things are 0.35 seconds, and that's our normal experience. We expect that kind of performance, and then suddenly things are getting out of hand here. So these are errors in ArcGIS Server that are happening. for a particular reason of simulation. But this is kind of what you're looking for. You're looking for these sort of bellwether HTTPs that you know that your audience needs. And so you keep monitoring them, and if there's a change in them, then you know that there's a problem. The really big and important section is infrastructure. And we can monitor processes, we can monitor terminal services, systems, both Linux and Windows, and also VMware. This is a very important category. We have all the high-level items to keep track of your system, and every system is going to monitor those items. It'll monitor all the disks, all the page files. It will monitor the disk activity, the processor, the memory utilization. And these are really valuable to keep your system going. If you... go ahead.
I'm afraid that we have to cut short your demo. We are out of time. So thank you, Frank. Just really quickly, where's 3?
Right there. Yeah.
Okay. Do us a favor, please provide the survey. We're here available for your question. For those of you who have to run, thank you very much and enjoy the rest of the conference. For those of you who have questions, we're here, Garrett is here. So thank you very much again.